Okay, so we're still in the chapter probability today, but just moving on to a new term, and it's called relative frequency. Now, relative frequency is an estimate of the actual probability of an event occurring. Okay, so the formula for a relative frequency is frequency all over the total number of trials, which is pretty much the same as probability, but we just use relative frequency because for some events it can be very difficult to work out the probability of an event. So we use kind of like statistical evidence from observation or experiments to determine the experimental probability. Okay, so the relative frequency of an event is a proportion of times that the event happens in a sequence of trials. But it's pretty much the exact same as probability. It's just that some cases it's difficult to determine the actual probability. So if we just go through examples and make a little bit more sense and get it clear in your head. Okay, so a survey shows that 80 out of 100 people own a car. Find the relative frequency of a person owning a car. So it's frequency all over the total number of trials. So the frequency of someone owning a car is 80 out of the total number of trials, which was 100. So the relative frequency on this question would be 80 out of 100. So remember, 80 out of 100, we always break it down to its simplest form, and you can leave it as 0.8 or 80%. So example 2 then, so the question is, a hurling team has won 12 games out of 25 in their season so far. Estimate the experimental probability as a decimal that they will win their next game. Okay, so experimental probability is the same as relative frequency. So it's frequency or number of times an event happened. So we want to determine what are the chances that they will win their next game. So the frequency of how many times they've won is 12 out of the total number of trials, which would be 25. So the relative frequency for that question then would be 12 out of 25, and as a decimal that breaks down to be 0.48. So just take a note of this one. So it's important to note that increasing the number of times an experiment is repeated generally leads to a better estimate of the probability. So the more trials that carried out, the closer the relative frequency will be to your actual probability. Okay, so we'll go through another example here. So a fair 6-sided die has its face painted red, white or blue. The die is thrown 36 times. Here are the results. So we had 7 red, 11 white and 18 blue. Based on the results, how many faces are painted each colour? So the question is how many faces? So remember, in a cube there is 6 faces in a cube. So the first thing we have to do is we have to find the relative frequency for the blue, the white and the red. So getting the relative frequency of the blue, so remember it's the frequency all over the total number of trials. So there was 18 blue out of the total, which was 36. So it's 18 out of 36 would be a half. Then I'll just do the relative frequency of white. So there was the frequency of white is 11 out of the total is 36, which is a third, approximately a third. And the relative frequency of getting a red would be 7 out of 36, which is approximately 1/6. Okay, so that is getting the relative frequency. Now it says, though, based on the results, how many faces are painted each colour. So we know that the relative frequency of getting blue is a half. So it would be a half of the total number of faces. So that's where we're getting a half by 6. So 3 faces will be blue. For the white, we worked out to be possibly a third. So it's a third of how many faces. So it's a third of 6, because remember there's 6 faces in the cube. So that would be 2. And then if you're getting how many faces would be red, well, we got the relative frequency to be a sixth. So it's 1/6 of the total number of faces, which is 6, which is equal to 1. So example here then would be 50 cars are observed passing the school gate. 15 of these cars are red. Use these results to estimate the probability that the next car to pass the school gate will be red. Well, the probability is the same as finding the relative frequency. So it's the frequency, which is 15, because we're looking at red cars, all over the total, which is 50. So at the start, always get into the habit of writing down the formula first. So it's frequency of red cars, because that's what we're looking for, which is 15, all over the total, which is 50. So 15 out of 50, and you know it always with a fraction, we have to break it down to its simplest form, and that would give me 3/10. Okay, so doing this example here then, it says Kira surveyed the colours of vehicles passing her home, and here are the results. So 6 red cars passed her home, 10 black, 24 silver, 4 green, 12 white and 8 others. So the question is then, calculate an estimate of the probability that the next car to pass will be silver. Okay, so an estimated probability is the same as getting the relative frequency, which is the frequency or number of times that the event happens all over the total number of trials. So in this question here, we know that the frequency, it will be silver. So we have that, so that's 24 silver cars passed, but we don't have the total yet. So the first thing we do is we have to calculate the total, and to get the total then we just add up all the cars that pass. So we're adding up all the frequency. So the first thing we do is we get the total. So I'll just write down the total then. And then we add up all our frequencies. So it'll be 6 plus 10 plus 24 plus 4 plus 12 plus 8 to give me a total of 64. So then going back to the estimate then, which is the relative frequency, it's the frequency, which is 24, out of the total, which is 64. So then the relative frequency of getting a silver car would be 24 out of 64. And we always simplify a fraction down to its simplest form. So that would give me 3/8. So this question here will be our final example. So Owen is carrying out an experiment dropping a spoon. He records whether the spoon lands up or down. Copy and complete this table for Owen's results. So the number of drops, or the number of trials that he's done, is 5, 10, 20, 25, 50 and 100. And the number of times it landed up was 3, 7, 11, 15, 32 and 63. So the first thing is copy and complete this table. So we're getting the probability that it will land up. So in this case then it was the frequency all over the number of trials. So it's 3 out of 5, which is 0.6. For 10 trials, it would be 7 times it landed up. So 7 out of 10 would be 0.7. So we need to finish off the remaining probabilities. So for 20 trials, it dropped 11 times. Okay, so that would give me 11 out of 20, which would give me the probability of 0.55. The next one then, it landed 15 times, it landed up out of 25 drops. So we must get the probability. So that would be frequency all over the number of trials. So that would give me 15 out of 25, which would give me 0.6. Then the next one to find the probability was the number of times it landed up was 32. So that would be the frequency all over the number of trials was 50 trials this time. So that works out to be 0.64. And then out of 100 trials or 100 drops, it landed 63 times up. So that would be 63 out of 100, which would give me 0.63. Okay, so that's just filling in the table there, calculating the remaining probabilities. So the second part of this question says, what do you think would be a reasonable estimate for the probability of this spoon landing up? And give your answer as a decimal correct to 1 decimal place. So remember earlier on in the clip, I was saying that you need to know this, which states that increasing the number of times an experiment is repeated generally leads to a better estimate of the probability. So the more trials that you do, the closer you get to the actual value of probability. Okay, so that the number of drops here relates to the number of trials. So we had 5, 10, 20, 25, 50 and 100. So we're going to look at the results when the trials get bigger. So when the trial was 25 times, okay, or 50 times or 100. So when it was 25 trials, we got 0.6. When we did it 50 times, it worked out to be 0.64. And when we did it to 100, it worked out to be 0.63. Okay, so the more times you do it, the closer you get to the actual probability. So this, it says, give your answer correct to 1 decimal place. So we have to look at, we'll say 25 trials, 50 trials and 100 trials, because our trials are increasing, and we have 0.6, 0.6 to 1 decimal place here, and 0.6 to 1 decimal place. So you'd give then that the reasonable estimate for the probability of this spoon landing up would be 0.6 to 1 decimal place.